Okay, to start out, let's graph this. I'll put some axes on there. And it looks like A is at the point 1, 1. B is at the point 2, 4. And C is at the point 3, 1. Alright, so it looks like an isosceles triangle. I'm just going to make sure it really is an isosceles triangle by seeing, okay, how much it looks like I had to go up by about 1, 2, 3, and then over by 1. And then same thing on the other side, is up by 3 and over by 1. So I see that there is symmetry, and so the left side of the triangle is congruent to the right side of the triangle, and that would make this an isosceles triangle. It also happens to be an acute triangle because the largest angle is an acute angle. Alright, next one. Okay, the point 1, 1. And the point 1, 4. So 2, 3, 4. Notice how I'm trying to space them all the exact same amount. Then 5, 4, so over by 1, 2, 3, 4, 5. Right there. Alright, I can tell that since I have a vertical segment right here and I have a horizontal segment right here that there's a 90-degree angle. So this is a right triangle. Which means that the longest side, sometimes called the hypotenuse, is that's going to be the longest length, and then I have a shortest side over on the left, and then a medium-sized side at the bottom. So since all three sides are different lengths, this is going to be a scalene triangle. A scalene right triangle, since the largest angle is a right angle. First thing I'm going to do is focus on the information that I'm given, the fact that this is a 75-degree angle, and the fact that there are these tick marks show that this segment right here is the same as length as this segment right there. So it looks like they're all part of a triangle here, and that would be an isosceles triangle. Isosceles triangle. Triangle. So that means if two sides of the triangle are the same length, then two of the angles are going to be the same amount of degrees, this angle right here and this angle right here. So it looks like this angle is also a 75-degree angle, so that would mean that x equals 75 degrees. Next, I want to see if I can figure out what y is. One thing I notice is that this angle right here, that's part of the isosceles triangle, I could figure out what that is because the three angles in the isosceles triangle are going to add up to equal 180 degrees. So let me see, let me give this angle a name for a second. Maybe I'll call it angle M. And that would mean that 75 degrees plus 75 degrees plus however many degrees angle this angle down here is in the isosceles triangle, those are going to add up to 180 degrees. And the reason I know that is because every single triangle in the world, the three angles of the triangle will add up to 180 degrees. It's not possible for them to add up to anything else except for 180 degrees. I'm going to combine the two 75s to be 150. So now I have 150 plus m equals 180. I'm going to take away 150 from both sides, and I get that m is equal to 30. And so you might be wondering why I even care how big this angle is. And the reason is because if I find out what this angle is, I put it 30 degrees, then I can use the fact that this whole angle here is a right angle to figure out what y is, because 30 degrees plus whatever angle y is going to equal 90 degrees. So I'll take away 30 from both sides, and I'll find out that y is 60. So that's a 60-degree angle there. So y equals 60, x equals 75. All right, for this next one, I'm going to first focus in on the parallel line symbols that show me that this line right here is parallel to this line right here. And I can also see that there is a transversal going through both of those parallel lines. Because of that, remember whenever you have parallel lines and there's a transversal going through them, the corresponding angles will be the same. So I'll mark two corresponding angles right here. Those angles are both going to be 40-degree angles. All right, so now I can see that with this triangle right here, that all the angles in that triangle will add up to 180, so I think to myself, okay, I'll just write x plus y plus 40 equals 180 degrees. But see how I have an x and a y in the same equation? If I take away 40 from both sides of this equation, all I know is that x plus y equals 140. So that could be like 100 for x and 40 for y, or it could be 70 for x and 70 for y, or 60 for x and 80 for y. So I'm going to need more information before I can figure it out. I've noticed I haven't used the fact that with these tick marks here show me that all three sides of this triangle are the same length, which makes it an equilateral triangle. And remember, whenever you have an equilateral triangle, all three of the angles are also the same size. They'll have the same amount of degrees. And since all of the angles in a triangle add up to 180, that means that it has to be split evenly between three angles. So 180 divided by 3, I'm going to get 6. So 60 degrees for each of those angles. Right, so 60, 60, 60. So how does that help me at all? Well, one thing that I'm going to notice is that these three angles here, because of the straight line, those three angles must add up to 180 degrees. So I'm going to write that 40 plus 60 plus x, the x got a little bit covered up, plus x is equal to 180 degrees. So I'll combine the 40 and the 60 and I'll get 100 plus x equals 180 degrees. And then that means that if I take away 100 on both sides, the x equals 80. All right, now that I know that x equals 80 degrees, then it should be easy to find out what y equals because of the triangle. I'll just use this equation that I already wrote down now that I know what x is. So 80 plus y equals 140. And then taking away 80 on both sides, I get that y equals 60. So there are my two variables that I solved for. X equals 80, y equals 60.